Okay, welcome back again, class 6. Today in physics, we will learn about matter. In the earlier classes, I had defined for you what is matter. There were videos given to you regarding matter, definition of matter. Matter consists of atoms and molecules. Okay, atoms are substances having been made up of similar kinds of substances. Okay, atoms, when they combine together, then they form molecules. Now, molecules with similar atoms or molecules with different kinds of atoms also can be there. So, that we have studied in the previous class. Now, states of matter we will learn. This you have also learned in your previous class also, in class 5 in science subject. There are three states of matter: solid, liquid and gas. And matter consists of molecules. So in solid, liquid and gas, how these molecules are arranged, that we discussed in the first part. In solid and liquid and gas, this is the arrangement of molecules. Solid, the molecules are very tightly packed. As you can see, these are the molecules representing solid. Okay, in this you see that the molecules are so tightly packed that there are hardly any gaps between each molecule or between two molecules. The gaps are hardly noticeable. See, the molecules are arranged in rows. Okay, this is first row, this is second row, third row, fourth row, like that. Liquids, they are arranged in rows, but the gaps between the molecules are a little bit more now. So we say that the molecules are loosely packed. Notice this word packed. Solid and liquid, I have mentioned this word that they are packed. In solid, tightly packed. In liquid, loosely packed. Packed means the arrangement is there in a particular sequence. Here the arrangement you have been shown is the arrangement of rows. First row, second row, third row. First row, second row, third row, like that. But if you consider gas molecules, they are not at all packed. See, there are no rows. Okay, no rows. They are simply roaming here and there. They are not arranged in rows. So there is no packing of molecules. The molecules are left alone and they move here and there according to their own wish and will. But the movement according to their own will doesn't happen in solid and liquid. In liquid, movement is there very slightly, but it is restricted to certain level. But in gas, the movement happens randomly. Okay, this molecule right now may be here. In the next moment, this molecule might have come here. But in liquids and solids, we don't see that random movement of molecules. So we say gas molecules are not at all packed. Whereas solid and liquid, they are packed. In solid, tightly packed, and in liquid, loosely packed. Okay, the second property of matter in regards to compressibility. Now, what is compressibility? Compressibility is like a sponge. You must have compressed sponge. You take it in your hand and you press it. What happens to the sponge? The size becomes smaller. Solids, the molecules are very tightly packed. Hardly any gaps are there. For compressing, you need gaps between the molecules. But if there are no gaps between the molecules, like a sponge, the particles have gaps in between them. So when you try using force, you can actually compress them. Compressing means to reduce the size of the substance by using force. So here hardly any gap is there between solid molecules. So when you try to use force, these arrows that I have given are the positions of applying force. Okay, there the force is being applied on solid. But if gaps are not there, will the distance between the molecules reduce? If already they are already near to each other, when you compress, you bring the molecules near to each other, right? But if they are already near to each other and no gap is there, then you cannot compress them anymore. So in solids, you cannot compress. So cannot be compressed. Solids cannot be compressed. Now in liquid, we see the gaps are now bigger as compared to solids. The gaps in molecules of liquid, even though they are packed, but the gaps are little bigger. So you can use force and you can actually bring the molecules nearer to each other, but very slightly. Okay, very less. Compressible, but very less. So I have written here, liquids can be compressed slightly. Now for gas, the gaps are very high. It is very easy to compress gas molecules. I'll give you one example. You have those gas cylinders in your house, right? In that gas cylinder, you have the value written 14.5, 15.5 kg. Okay, that's the amount of gas that is present in your cylinder. What is happening is that much amount of mass of gas is compressed and put inside the cylinder. But now if your cylinder leaks, then what happens to that gas? That gas spreads in the entire room and fills up the space of the entire room. So now the gaps between the molecules becomes very big because they are occupying a greater space. The space in the gas cylinder was very less compared to the space of the entire house or the room. So the gas is spreading. So gaps are very high in gases. You can compress them very easily. So in the gas cylinders, the gases are actually compressed and then put inside the cylinder. So that much amount of gas which is actually occupying the entire room can be compressed and put inside the gas cylinder. So gases can be compressed highly. Okay, highly compressible. Gases are highly compressible. So compressibility depends on gap between the molecules. In solid, gap is not there, hardly there, so cannot be compressed. In liquid, gap is little bigger than the solid, so it can be slightly compressed. In gases, the gaps are very big between the molecules. The gaps are very big, so it can be highly compressed. So compressibility we have discussed in the 3 states of matter. Next comparison between solid, liquid and gas is by their shape. Shape of solid. Molecules are close together. So now remember one thing. If the molecules are close together, then the power by which they hold each other, that power is known as bonding. Bonding is the attraction force. You know what is attraction? By attraction we mean pulling between each other. Molecules, they actually pull each other, and the force with which they pull each other depends on how far or how near the molecules are to each other. It's like magnet. You take 2 pieces of magnet and bring them close to each other. As you bring them close to each other, you will experience that the force with which they are attracting each other is more. So attraction power depends on the distance between the 2 magnets. The nearer you bring them, the greater the force between them is. In this also the same thing. In solids, molecules are very close to each other, so they pull each other also very strongly. In liquids, the gap is there between molecules. So as you increase the gap between magnets, the strength between the 2 magnets also reduces. So here also the gap is now more. So the strength with which they attract, the molecules attract each other is reduced. So the bonding between the molecule is less. In gas, the gap is very high. So there is no question of one molecule attracting another molecule, because they are very far away from each other. Okay, so attraction power depends on the gap. More is the gap, lesser is the attraction force. So now here the attraction force between molecules is very high, so they have a definite shape. Why? Because the molecules hold each other and don't let each other move from their place. And if they don't move from their place, will they change their shape? No. Molecules will stay close to each other, they will stay in their own position, they will not change their shape. But in liquid and gas, gap is there, so the molecules will actually move. They will not be held in one position. They are free to move about in liquids and gases. So in liquids and gases, the shape will not be definite. So there is no definite shape. In whichever container you put water is a liquid, right? You take water and put it in glass, it will take the shape of glass. If you take water and put it in a dekchi, the water will take the shape of the dekchi. Similarly, any container you put water in, it will take that shape. Gases also, in whichever container you put them, it takes the shape of that particular container. Alright? So, This particular difference between solid, liquid and gas is based on shape. Shape depends on gap. Gap, more is the gap, lesser is the attraction force between molecules. Less is the gap between the molecules, attraction force is stronger. And if attraction force is stronger, then the solids are rigid or they have a definite shape. Their shape doesn't change. And rigidity means they are held strongly. So in solids, they are held very close to each other. So the attraction powers of molecule is very strong. So we say solids are rigid. Whereas liquids and gas, they are not rigid. Because molecules are not attracted to each other strongly. They are free to move from their own position. But in solids, the molecules cannot move from their positions. They will remain in that one particular position only. So this is the comparison between solids, liquid and gas depending on shape and rigidity. Okay, the next comparison is based on volume. Volume means space occupied. Now take example of a stone. Stone is solid. You take stone, put it in a deckchi. Will its space occupied by the stone will increase? No, it will remain as it is. Its shape is fixed, so its volume is also fixed. Take the stone from the deckchi, you put it in a glass. Does its shape change? No, it will remain the same as it was. So in that way also, how much space that stone is occupying in the glass is also the same. No change will be there. But in gas, we see this doesn't happen. Even in liquid also. Now in liquid, the volume or the space occupied is expressed in liters. For example, take a Pepsi bottle of 1.5 liter. Okay, 1.5 liter ka Pepsi. You take that Pepsi, pour it in a deckchi. From 1.5 liter, will it become 2 liters? No, it will remain 1.5 liters only. So in liquid also the volume remains same. In solid also its volume remains same, but not for gases. Now gases, the molecules, they are free to move anywhere. In liquid, it's not like that. Okay, in liquid I'll tell you how it is. Okay, in liquid there is a surface. This surface also is made up of molecules. It's like a boundary for the liquid. So liquid can move anywhere down. This molecule can move down this way. So coming up, this molecule can move this way and down, but it will not go up. All the molecules over here, they will move down, left, right, but not up, because this is the guarding or the boundary line. These molecules act as a boundary line for all the other molecules which are down. So this is called surface molecules. So in liquid, this surface molecules checks the other molecules which are below them. So this is like a boundary. All the other molecules which are below them can move anywhere within this boundary. So the boundary for liquid is there. So wherever there is a boundary, that means you can move anywhere within the boundary, but you cannot go outside the boundary. In solids, each and every row acts as a boundary for the next row of molecules. So each molecule in one row is fixed in its own position. No movement is allowed. Whereas in liquid, the movement is allowed within the surface. So if the 1.5 liter Pepsi bottle has a boundary, the boundary is there in the liquid. Say this is one glass of water. This is the surface we say. Okay, this is the boundary for all the other molecules which are below this boundary. So these are the molecules below. So each and every molecule over here within this boundary, this can move down this way, but it cannot cross the boundary. So this boundary, suppose here it is 1.5 liter from here to here, suppose it's 1.5 liter. This will not change. Surface will not go up or down. It will remain where it is. So if it doesn't go up or down, the volume also will not change. in liquid. So in solid and in liquid, the volume doesn't change. In liquid, the volume changes. In gas, the volume changes. In solid, the volume doesn't change. So this is the comparison between solid, liquid and gas. But gas, there is no surface. There is no boundary for the molecules of gas. That's the reason I was telling, no? A gas present in the gas cylinder, when it is compressed and kept inside the cylinder, the amount of space it occupies is the space within the cylinder. But if you make the gas to leak, then it will occupy the entire room. Now the space occupied by gas will increase. It is equal to the entire room. So space is volume. So in gases, the volume is not fixed. It will occupy the entire available space. Whereas in liquid and solid, the volume remains fixed. It doesn't change. For the next comparison, the comparison parameter is diffusion. What is diffusion? Let me explain to you. Suppose there is one substance whose molecules are like this, and there is another substance whose molecules are round-like molecules. Okay. Now, in both the substances, you can see there are gaps. Here also and here also. Gaps are there between molecules. In diffusion, what happens? This substance comes in this substance, or this substance mixes with this substance, and then after mixing, how the molecules will look? Both more types of molecules. Okay, first this molecule, then this molecule. See, this molecule comes and fills the empty space between these two molecules, so it is coming and occupying here. Similarly, this particular molecule fills the gap between these two molecules. See, between these two molecules, now this molecule is there. So diffusion means mixing of the molecules of two or more different substances. But this can only happen if gaps are there between the molecules. Alright. So in liquids and gases, we see the gaps between the molecules. But in solids, is there any gap? No, the gaps are not there. So can you imagine another kind of substance coming and mixing with solid molecules? Or two solid molecules coming and mixing with each other? Cannot happen. So between solids, diffusion does not happen. Okay? No diffusion. But in liquids and gases, diffusion occurs. For liquids and for gases, diffusion can take place. But in solids, there is no chance of diffusion taking place. Okay, the next comparison between solid, liquid and gases are based on melting point and boiling point. Now, first of all, we need to know what is melting point and boiling point. Melting point is a temperature, boiling point also is a temperature. Temperature at which solid changes to liquid is called melting point. You know, solids can be changed to liquid, liquid can be changed to gas. So the temperature at which solid changes to liquid is called melting point, and the temperature at which liquid changes to gas is called boiling point. Okay. For different liquids, solids, you have different melting points and boiling points. Alright. For solid, melting and boiling point both are above room temperature. Above room temperature means temperature which is more than the temperature of your room, or normal temperature. Okay, the normal temperature which is in your room. So both melting and boiling point for solids are above room temperature. In liquid, melting point, the temperature at which solid changes to liquid, is below room temperature for liquids. But the boiling point, the temperature at which liquid changes to gas, okay, that is above room temperature. And for gases, you know, gases also can be in liquid and solid form. Gases can be converted into solids or liquid form. So in that, gases, both melting and boiling point are below room temperature. So this is the comparison between solid, liquid and gas based on melting point and boiling point. The last comparison is based on kinetic energy. Now what is this kinetic energy? Energy that is there in particles which move. Okay, moving particles have kinetic energy. Solids, particles don't move, the molecules are fixed in its position. So there is no movement, only the movement that is there is staying within its own position and vibrating. Solids, the molecules stay in their own positions and they vibrate. What is the meaning of vibrate? Like you take a rubber band, stretch it and then you pluck it in the middle. It starts to vibrate up and down, right? But after the vibration stops, the particle comes to its original stretched position. So solids also, they keep on vibrating. There is no point at which the vibration stops. They keep on vibrating, but they stay in their own positions. Liquids and gases are free to move. Liquids are free to move within the surface. Remember that boundary thing that I had told. There's a boundary for liquids. That boundary is called surface. So within the boundary, the molecules move. Gases have no boundary, so they move here and there. Maximum movement is there for the molecules of gases. So as I said, kinetic energy means movement, energy more. So movement is more, then energy will be more. Kinetic energy will be more. So in gases, the movement is more. So kinetic energy of gases is the maximum. Lesser than gases is the kinetic energy of liquids. In liquids, the movement of molecules is lesser than gases. So kinetic energy also is lesser than gas. And the least kinetic energy is there for solids. Okay. For solids, the particles don't leave their original positions and go to another position. They stay in one particular position and vibrate, move to and fro from their mean position, original position. So the least amount of kinetic energy is for solids. Greater than solid, the kinetic energy is there in liquids, and the greatest kinetic energy is there for gases. Okay, all these differences between solids, liquids and gases are given in this page number 13 of your book in this particular table. See, the properties are given here and the comparison is there between solid, liquid and gases based on these properties. Go through this table and go through my video again for understanding the differences between solid, liquid and gas.